All right, so in this section, we're going to be learning how to find values of x given the percentage of area that the percentage of area underneath a curve. Okay, so we're going to start with an example. It says we want to find the z-score that has 96.16% of the distribution area to its right. Okay, so what I would do with this is similar to what I have instructed you guys to do in the other two sections, is to draw a picture first. Okay, so when drawing a picture, remember that they all will look pretty identical. Okay, so we've got our bell curve. Okay, right here in the middle, because we're looking at z-score, remember that z-score is a standard score, so we're looking at a normal distribution. So this point right here is 0. Okay, and we're looking for the area, the z-score that has an area of 96.16% of its area to the right of it. So, in other words, the z-score that we're looking for is probably going to be somewhere back here. So we're looking for this area back here. Okay, so we're looking for this stuff. So our z-score is probably going to be negative. Okay, so the way we're going to do this is I'm going to give you guys a couple of steps, okay? So to calculate the z-score given an area, you're going to, go to second, so this is in your calculator, second vars. 2, you're now, instead of doing the normal CDF, you're actually going backwards. So if you're going backwards, you're going to go to inverse norm. And this is how you're going to fill it out. So the first line is area. Okay, so you're going to write the percentage. Now the percentage is going to be written as a decimal. Then the mean, if we're looking for z-scores, remember the mean is always 0, and the standard deviation is 1. Okay, and you're going to go to the enter. And what I want you to remember is that this is always going to be calculating the area to the left. So only calculates the area to the left. Okay, so what this is actually doing is it's finding the z-score over here and finding the area back behind the z-score. Okay, but one thing you need to remember is that it's symmetric. Okay, so if it gives you the positive z-score, okay, it's just the area the area behind it or to the right is going to be the opposite. So when you calculate this, it's going to give you the area is equal to 1.770, or sorry, not the area, the z-score is equal to 1.770. Okay, so to get the area to the right, so the z-score where the area to the right is that much, you're simply going to change the sign. So it's actually going to be z is equal to negative 1.770. Okay, so you're just changing that sign. Okay, the next part is saying, well, we want to find the positive z-score of the distribution of the distribution's area, which lies between negative z and positive z. Okay, so again, we're going to draw our picture here. Okay, so we've got our picture right in the middle. Again, we have 0. Okay, so again, we're just looking for the z-scores. And we're looking for the positive z-score with 95% of the area in between it. So we have a negative z-score here. We have a positive z-score here. Remember that these are symmetric, so these should be the same, just opposite signs. Okay, and we're looking for the area back in between these two. Or we're given the area in between these two. Okay, now the way we're going to do this is I'm going to calculate. I need to go ahead and figure out what the two tails are. So I need to figure out what is the area back here and what is the area back here. So that red portion. Okay, so if the area in between is 95%, that leaves 5% for the tails, okay, total for the tails, which means that we need to divide this by 2, okay? So this actually represents 2.5%, and this represents the other 2.5%, okay? So now we can calculate, right? So you can say we can find the area, or we can find one of the z-scores, okay? Remembering that it always only calculates to the left, okay? So I'm going to go to second vars down to inverse norm. The area that I'm going to put in here is, I'm going to go ahead and say, let's calculate this. So let's calculate the negative z-score, and we'll change it to the positive z-score. Okay, so let's put in for the area 0.025, and then we're going to leave these two facts alone. So it should still be 0 and 1, and then you're going to click enter, and you get out a z-score of negative 1.960. Okay, and remember, if you want the positive one, these are symmetric. So all I need to do is simply flip the sign, and now we have the z-score, that the upper z-score. Okay, so that's all we're doing. If you have questions on that part, just let me know, and I'm more than happy to help you out. All right, so now we're taking a look at the percentiles. Okay, so percentiles are always referring to the area to the left of the curve. So I'm going to draw down here, since I'm running out of room, I'm going to draw kind of a general bell shape. Okay, so I've got 0 here, and we've got this information. So this is saying the 10th percentile. Okay, so number 1 is saying the 10th percentile. Okay, so in other words, we're looking for the area to the left, or the z-score that represents the area to the left of 10%. Okay, so we're looking for this z-score, and the area underneath the curve should be 10%. Okay, again, following these steps, we can calculate the area, and we'll find that z is equal to negative 1.28. So we're going to round it to 3 decimals, to 282. Okay, let's do 20%. So 20%, again, second vars, inverse norm. The area is what's going to change here. So the area for this is going to be 20%, so 0.2. And when you calculate that, again, I'm just leaving this to you. So the area under the curve is 20%. You have negative 0.842. All right, and then finally, we have this. This is our 99th percentile. This should include almost 100% of our data. Okay, and we have talked about how at 3.5 z-scores, that includes nearly 100%. Okay, so let's go ahead and calculate this. So again, this is going to be looking down here at the graph. We're looking at the fact that 99% of all of the area is under the curve. Okay, so all we're changing is our percentage, and we get z is equal to 2.326. All right, and so that's how you're going to calculate percentiles, or the z-score for percentiles. Now, down here, we're going to talk about transforming a z-score back into an x value. So something you do need to remember is that to calculate a z-score, it's simply x minus the mean divided by the standard deviation. Again, this is one of those things that you absolutely need to have memorized in order to have success in this chapter. Okay. Now, we want to go ahead and calculate so that we can solve for x. So given a z value, how can we solve for x? Well, one way that we could do that is by solving this equation here for x. Okay, so that's what we're going to do. Okay, and I'm going to start that by simply multiplying both sides by whatever the denominator is. Okay, so multiplying both sides by sigma. Right, these go away, and I'm left with z times sigma is equal to x minus the average. Okay, and then to finish solving for x, I can simply add the mean to both sides. And what we're left with is that x is equal to the mean plus z times sigma. Okay, so the actual data entry can be calculated using this. Now, obviously, you can go back and you can just have this thing memorized and solve for x if you need to. But this is another good equation to kind of have back in your arsenal. All right, So let's do an example using this. It says a a veterinarian records the weight of dogs treated at a clinic. The weights are normally distributed. Again, this is one of those keywords you absolutely have to be looking for here, normally distribution. Okay, with a mean, okay, so I'm going to go ahead and write this part down. So the mean is 52 pounds, and the standard deviation is 15 pounds. Okay, so again, the keys here is to remember to make sure you're looking for that average and that standard deviation. Okay, we want to find the weight that corresponds to each of those z-values. In other words, we're changing our position scores back into actual data entries. All right, so looking at part A, we have, I'll go ahead and write this down so we have it, but x is equal to the mean plus the standard deviation times z. Okay, so we have that x is equal to the mean, which is 52, plus the standard deviation, which is 15, times negative 2.33. I'm going to leave this to you guys to calculate in your calculator, or to at least check me, but you get about 17.05. And remembering that this represents a data value now, we need to label it. So this would be pounds. Okay, so a dog that is about, that's 2.3 standard deviations behind the mean is about 17.05 pounds. All right, let's look at this one. So again, we're going to calculate the same way. So I've got x is equal to the mean, 52, plus 15 times a standard deviation, 15 times the z-score. Okay, calculating this says that a dog that is 3 standard deviations away from the mean is about 97 pounds. Okay. And then finally, this last one, again, setting it up the exact same way. So we've got x equals 52 plus 15 times 0.58. Using your calculator, it gives you 60.7 pounds. Okay. So again, it's just about being able to kind of memorize and plug these things into your calculator. All right, so let's do an actual word problem example. It says a researcher tests the braking distance of several cars. The braking distance from 60 miles per hour to a complete stop on dry pavement is measured in feet. Okay, so we're all of these cars are going at 60 miles an hour, and then they they stop as fast as they can on dry pavement. So we're using the same test for each of these cars. The braking distance of the sample of cars is normally distributed. So again, there's our keyword. It's normally distributed. Okay, the mean is 129 feet and a standard deviation of 5.18 feet. We want to know what the longest distance of these cars could have and still be in the bottom 10%, okay, or 1%, my bad. So the bottom 1% is what we're looking for. So I'm going to draw my picture. Okay, we've got we'll go ahead and use a z-score, so z-scores. The 1%, so the area behind 1% would probably be in this little bitty tail right here. Okay, so 1%. Okay. We're looking for this z-score here. Okay, and so we're going to do this by going through these steps. Okay, so again, it's going to be second vars, inverse norm. The area is 1%, which as a decimal, that's 0.01. And then you're going to make sure that your average is still 0 and your standard deviation is 1. And then we're going to calculate. Okay, so this is already looking at the bottom 1%, which means it's behind the z-score. So when you do this, you get a z-score. Okay, I apparently forgot to do this part. So second vars down to inverse norm, the area is 0.01. And you get a z-score of negative 2.3. We'll go ahead and round it to 33. Okay? So this represents the position where 1% is behind it. Now, we want to go ahead and calculate for the x value. Okay, so what is the longest distance? That tells us that it's looking for an x value. Okay, so we're going to say x is equal to the mean, which is 129, plus the standard deviation, so 5.18, times the z-score, so negative 2.33. Okay, and we come up with approximately 100, and we'll go ahead and round to 117 feet. Okay, so the bottom 1%, the furthest braking distance that they could have is about 117 feet. Okay, so another way to think of this would be that 99% of the cars have a braking distance of more than 117 feet. 117 feet, okay, which is pretty short. Okay, next one. It says it says the lengths of time employees have worked at a corporation are normally distributed. Okay, again, there's that key word that we're looking for, with a mean of 11.2 years in a standard deviation of 2.1 years. In a company cutback, the lowest 10% in seniority are laid off. What is the maximum length of time an employee could have worked and still be laid off? All right, so again, we're going to calculate this. I like to draw it out. So we've got 0, the lowest 10%. So when we're saying the lowest 10%, it means that we're looking for the area behind something. Okay, and we're looking for the z-score. Now, the z-score, because it's less than 50%, should be negative. Okay, so again, we're going to go back through, and we're going to calculate our z-score. Okay, so calculating our z-score, we're going to go into second vars, down to inverse norm, change our area to 0.1, and then we're going to see what we get. And we should have the z-score of negative 1.28. Okay. Then I want to convert this from a position back into our unit of time, which is years. And the way we do that is by simply saying 11.2 plus 2.1 times the z-score, or the position score. Okay, and when we do this, we get approximately 8.5 years. So if you have worked in this company or this corporation for at most 8.5 years, then you can probably expect to be laid off. All right, and so that is everything that we're going to be covering in this chapter. If you have any questions, just let me know. I will